Hello folks, after a long time I'm back once again with our regular stuff. So this is 2022 October November paper 1-3 and the question number is 31. The question is concerned with the chapter current electricity. It says that a battery with a constant inner resistance, here this is R, is connected to a resistor of resistance 250 ohm. So I can write this R is equal to 250 ohm. The current in the resistor is 40 milliampere. So this current, which we say as I, this I is equal to 40 milliampere, which is equal to 0.040 amperes for a time of 60 seconds. So the time is equal to 60 seconds. During this time, 6.0 joule of energy is dissipated by the internal resistance. So here the energy dissipated is this much. So I write it as, it is heat energy, so I write it as HI. So H means heat energy and I means in the internal resistance. So that's equal to 6.0 joules. From these data we have to find what is the energy supplied to the external resistor. So we have to find the energy here in the external resistor. Let me name it as HR, and the electromotive force of the battery. So we need to find the EMF of this battery. So the amount of heat energy here can be found by the formula. Heat energy through the resistor is equal to I square RT. So it is simply I square into RT. And this is I equal to 0.04 squared into R is 250 into time is 60 seconds. So this becomes so 0.04 square into 250 into 60. It is 24 joules. So 24 joules. So as I go through the answers, I can see that these two will be rejected and only C and D remains, because it is asked us as the energy supplied to the resistor, which is this much. Now we need to find the EMF. To find the EMF, we need to find the PD here, which is the terminal PD, or we can say the PD across the resistor, and we can see the potential loss here. So if I add those two, it will become E. So first let us find this thing. So VR is equal to I into R, simply the current flowing through it into the resistance. So that's equal to I is 0.040 into R is 250. So this becomes 0.04 into 250, 10. So this is equal to 10 volts. So the PD across this resistor is equal to 10 volts. Now for this thing, what I need to find is to find the VI here. So VI should be equal to the energy used up here per unit charge. VI is equal to work required per unit charge or energy used per unit charge. We are given the energy used here, so that's why it's equal to the heat energy used here by the charge here. It's equal to 6.0 divided, this is I into T, equal to 6.0 divided I is equal to 0.040 and T is equal to 60. So this gives us, so 6.0 divided 0.04 into 60 joules. So that is equal to 2.5. So it is 2.5 volt. So it is 10 volt here and 2.5 volt here. So the value of E will be equal to, from Kirchhoff's law, we should have external voltage VR plus the internal loss here is equal to 10 plus 2.5, which becomes 12.5. So the EMF is equal to 12.5 volts. So the answer choice should be D. So D is the correct choice and C is the incorrect one.